Hello everyone, this is Alex McConnell from Intechnica. Welcome to this webinar. This is Designing Applications for the Cloud. It's going to be presented by our Technical Director here at Intechnica, Andy Still. And I just want to tell you a little bit about who we are in Intechnica. We're a digital consultancy here in Manchester, in England. And what we basically do is we do bespoke application development, that's business critical, functionally complex web and mobile applications. We do performance assurance, that's a holistic approach to application performance that we undertake. So that's all the way from management, design, engineering, auditing and testing. And finally we do cloud services, so we're an Amazon Web Services solutions partner. We organise the Web Services user group for the north of England. And we have a few software as a solution products as well, CloudFlex, which provisions test environments and development environments as well in the cloud, and Traffic Spike, which load tests in the cloud. So that's a little bit about us, but I'll pass over to Andy now, and Andy can tell you what you came here to hear. So here's Andy Still for you.
What I'd like to do is just give sort of a quick overview of some of the thoughts we've had and the problems we've suffered when we've been doing cloud development, because it is a very new subject. So hopefully just give you sort of a quick introduction to some of the problems you can see. So the first point, and I think this is probably a key point to cloud development, is that it's not traditional web development. And I think one of the problems you have as getting into cloud developers is it's easy to think that it's the same, and what you do for your traditional, that you would have done on your traditional web server, you can just do exactly the same that and put it up into a cloud environment. And I think to a certain extent you can do that, but by doing that you're probably losing some of the benefits of the cloud. So I mean, what we'll try and get across in this webinar today is the way that you can embrace a lot of the benefits of the cloud, but we'll also try and show you some of the pitfalls that you can easily fall into if you just go ahead and do things as you've always done them. Now, first, and I think a key element to the cloud environment is that the platform you run your application on is very likely a transitory platform. So you have to design your application on the assumption that the platform it's running on can disappear at any point, and it will recreate itself, possibly depending on the platform you're running on, but it will recreate itself not necessarily in the same state as it was. So you have to make sure that everything you have developed will work straight away when the system comes back up. And a key point is that you can't depend on local storage. So anything you store locally on the file system on the actual server could at any point disappear. And for that reason, the cloud providers all offer shared, more permanent storage. So we look at things like Amazon EBS or S3, Azure Blob Services. They're all designed to get around that weakness. So they offer permanent storage, and they will offer SLAs of permanence to those artifacts, whereas anything stored on the actual machine could disappear at any point. The next point is build to scale out. So the real benefit of the cloud platforms is that you can scale out very, very quickly and very, very easily. To a certain extent, using things like AWS EC2, you can scale up as well. So they have a very wide range of sizes of boxes, and you can easily scale up to that. But scaling out is the way to do it really with the cloud. It's the real power of the cloud is the ability to fire up a load more servers just for a very short time. Which obviously, to do that, you have to build your application appropriately. So the first and probably key one is componentize everything. You create everything as very distinct areas of your application, then you can scale out then by either moving components onto other servers, which is obviously the easiest way, And then when you're scaling back, you can have all those running on one servers. Have minimal interfaces between all those components, because obviously there's bandwidth considerations and there's overhead when communicating between servers. In the cloud environment, there's no guarantee of the amount of latency of communication you have between the servers. So keeping those communications to a minimum is best. And this ties back into what we were just talking about the transitory nature of the cloud. If you make everything idempotent, then things can fail halfway through, or calls can get lost in transit somewhere, and you can just make that call again without having to worry about the effect that has. Now, obviously, you realise that's not always possible, but it's a target you should be aiming for in this environment. The next one is, as far as data is concerned, is to try and shard your data where possible. So you're reducing your reliance on a single database. And I think the last one I've mentioned here is quite a key one, is everything needs to be made stateless. So we can't be reliant on always hitting the same server. This is good practice anyway, because obviously load balancing algorithms work a lot better when there's no people stuck to certain servers. But also with the transitory nature of some of the servers, ideally you don't want to be sort of forcing people to be logging in again or losing their state because the server they were connected to has now disappeared. Right, the next area I want to look at for cloud applications is around the area of data storage. And I think one of the things that definitely comes with the cloud is the ability to be a lot more flexible and imaginative with your data storage means. You hear the NoSQL movement sort of bandied around as one of the sort of major buzzwords at the moment. And one of the things cloud enables you to do, really, is to dabble in that and see whether or not that will work for you. So all the major cloud vendors offer one or more NoSQL solutions. So Azure runs table services, you've got Amazon SimpleDB, and now they've recently launched DynamoDB as well for high scalability. And the advantage of these really is that they're very, very flexible, and they're distributed so that they do scale a lot better. They're built for scalability. Now, the downside of that, obviously, coming from a relational background, which I imagine most people probably have done, is that you do lose your transactional integrity that you get with relational databases. So you can't guarantee using the NoSQL solutions out of the box that the data will be in a consistent state. It will be eventually consistent, and the degree of eventual consistency and the reliance on eventual consistency varies from solution to solution, and there are ways sort of building it in. But out of the box, the NoSQL theory relies on eventual rather than continual consistency. So for anything that the obvious ones are stock control systems, banking systems, anything that does rely on data integrity, NoSQL is probably not the way to go. But for a lot of things, NoSQL probably does the job, because you're not relying on right up to the millisecond consistency of data. NoSQL movement, generally, the flexibility of the queries you can do is a lot more limited than you'll see on the NoSQL database. And NoSQL is very, very fast when querying on primary keys, and can be much, much slower when doing more complex queries. And the other consideration when moving away from your standard relational database is that you will be moving away from the standardized language that we've got in SQL, which is fairly consistent across all database providers and is very familiar to all developers. So you are moving a little bit into the land of the unknown. So I think the thing is on that score is to consider what you're using the database for, considering how you'll be querying the database, and consider the ongoing maintenance of these solutions. But the NoSQL databases are definitely worth looking at if your application needs to scale. So they will scale infinitely more than SQL databases. And following on from that, and it's kind of a related subject, is that what you also get when you use these cloud vendors is you get a lot of other services that they offer. They do, and it's an ever-expanding toolkit that they're offering, but basically it's all the building blocks that they believe you need for building a highly scalable application. All these tools, they're all designed for scalability and fault tolerance. They're designed to have a low administrative overhead. They are pretty much all pay-per-use. And I think the thing with these services that I always think is sort of quite a key element is that the big cloud providers, Amazon, Microsoft, etc., these services are the services that they use for powering a lot of their own services. So in Amazon use SimpleDB for powering their own e-commerce site. So they're services that have to work from that point of view, because they are powering some of the most used services in the world. And for me, it makes sense to, if you're going down the cloud route, to not be looking at using sort of your own proprietary services if there is another service out there that is built to do the job. So I've put a quick list up here of some of these services that are on offer, and this is entirely looking at Amazon and Azure's native offerings. There are plenty of other services. I'm thinking of the likes of Heroku, Harbour, and a load of other kind of services that sit on top of Amazon. But I've just listed here, and this was just to show the amount of options there are just by using the native cloud provider ones without looking at third-party ones which offer equally good services. And this, you can see here from this list the range of different elements, from business intelligence right through to NoSQL and SQL databases and monitoring, scaling services, VPN. And this list, to be honest, is growing, particularly from Amazon, grows probably by 2 or 3 offerings every month. They're always releasing additional services. So it's worth monitoring their Twitter feeds and their blog posts and their signing up for their newsletters, because these new services do come out all the time, and it is hard to keep on top of all the new ones that are out there. Following on from that, I think it's quite relevant. For me, one of the major advantages of the cloud is that there's a lot of people, Amazon, Microsoft, for example, and then a lot of third parties as well, who offer these services, who offer cloud-based services on a pay-as-you-go kind of solution. And for me, as a cloud developer, you shouldn't be scared of using a hybrid solution of these services. Don't feel that if you start building something on Azure that you can only use Azure services. And don't feel if you start building on EC2, running your servers on EC2, that you can only use the EC2 offerings. And don't feel that if you go down the cloud route, that means you can't have anything in your traditional data center or on your own premise. Think out of the box a little bit. Look at all the services. Look at what does the job best for you, and then consider the sort of disadvantages of using a hybrid solution, which there will be bandwidth costs, potentially there will be latency, the complexity of managing multiple services, but think of the benefits and the risks. So, and I think just one final point on this is that don't think that just because your application isn't cloud friendly, so you may have very, very strong security or data protection requirements that mean you're uncomfortable moving to the cloud, but that doesn't mean the cloud's no interest to you. There may be areas of your service that will be ideal for the cloud. So perhaps, even though you can't run your application in the cloud, maybe you can do your test environments in the cloud with anonymized data, and that will solve you all your in-house scalability of test environment problem, get rid of all the bottlenecks and contentions around that area. So the cloud has a lot to offer above and beyond just as a hosting platform. Okay, I'm just going to quickly run through a few example hybrid cloud solutions. Again, this is just to show sort of the idea of sort of thinking outside the box a little bit on combining various solutions. So this first one I did, and this is one that we have implemented for someone, and they had a very sort of standard e-commerce offering, as you were. So they had a sort of product catalogue that you'd browse, add it to a basket, and then at that point you go through to their secure section where you'd pay by credit card. Now they had major PCI compliance concerns of moving their whole application to the cloud. They've gone through a long and quite arduous process of becoming PCI compliant on their data center offering, which they didn't really want to embark upon again. Now, at that point, there were no PCI compliant cloud offerings. Now there are, so they would have other options. But at that point, they basically didn't want to start messing with that again. So now what they did have was major capacity problems on the product catalog. Now, the actual secure area of the site had no such capacity problems. So what we looked at doing was separating their system so that the secure service stayed exactly the same, working in their PCI compliant data center, and we moved the catalog and the product browsing area, and basically the front end of the website, out onto a cloud environment where we could scale and contract the amount of service for that based on usage. We implemented then a NoSQL database for product management, and we just set a process going that as part of the administrative process, any changes to the SQL database were regularly farmed out to that NoSQL database. So we wrote a piece of middleware there that basically handled that translation between the two services. It's a fairly straightforward kind of mapping between two services, and then obviously we optimised the NoSQL database for the search algorithms that were on the front end. So that was basically solved their two problems and left them with a scalable system that could handle any amount of traffic that was thrown at it. Okay, now the next one, which is a sort of a similar service, basically involves moving their entire online presence out onto, on this diagram, Amazon EC2, Amazon AWS, I should say. So that uses a similar process to farm their relational SQL data out to a NoSQL database with a scalable web front end that is accessing that. What we've got in the back end now, on-premise, this particular company in this example would have a reliance on the on-premise system being continually up and fast, so that their team of people and possibly their call center people had access to this system, and it was reliable without any worries about downtime. But then whenever they make updates through the administration site, those are then farmed out to the web presence. So the web presence is more or less a read-only presence in this example. We've also got the regular data transfers to a SQL Azure database, which acts as in this case, just a warm backup for the on-premise SQL database. So that's again an example of how we're using SQL Azure as a backup server to the on-premise SQL database, and we're using the NoSQL database offerings from Amazon to power the online presence. Okay, and this is, again, a way of building a cloud offering around your existing web presence. So, again, a fairly common thing we see is that people have invested a lot of time and effort in getting their environment up and running in their hosted environment, and it's working and they're happy with it, and they don't want to spend the time and effort relocating it, refactoring it to work on another platform, but it's creaking a bit at the edge. Now they can scale up the various machines in their data center. They could possibly add more web servers, but what we looked at doing instead was trying to relieve the pressure on their web presence by putting a caching layer in front. So we use that fabric to cache some of the more commonly used content, to basically just take the pressure off the web server. We also took some of the pressure off the web servers, which were previously also doing some processing on the orders after receipt of the orders, and sending emails out. So we basically relieved that by taking that process off their hands. So when an order was placed, it just put the details of that order in the Azure messaging queue. We then had an Azure worker role, which was polling the messaging queue. So whenever an order came in, it did what was needed to be done to process that order, and then distributed email confirmation of it via Amazon SES. So again, this is an example of using the Microsoft Azure offering for caching and their messaging queue. We're using the Azure worker role for post-order processing, and we're using the Amazon email service for sending out emails at the end. So that's using the offerings from different companies to combine into one system. Right, now this is a key one. This is what a pitfall that is very easy to fall into because of the nature of how cloud services are offering, is that you have to be very aware of what you're paying for when you run these services. They're all pay-as-you-go, which is nice because it means that you can jump in and test the water with things and you don't have to pay very much. But it does mean you have to be very careful because it's difficult to set fixed budgets, and it's easy to, by sort of careless coding errors and architecture, to run up big bills that you don't actually need to. So an obvious one is bandwidth. So just minify your files and enable compression, so you are using the least bandwidth. Be more aggressive on caching, so don't be downloading things multiple times when you don't need to. And look at CDNs again. Going back to what we were talking about earlier of using multiple cloud services, there are various CDNs out there that you can use. So look into those. Then minimize database calls. This is particularly relevant on the sort of NoSQL offerings, which are generally pay per transaction. So if you can cache results in memory, then great. If you've got a complex process that may call the data sort of 20 times in one page, combine that into one query if you can. That is good development practice anyway, because obviously it'll be much more performant, especially with the increased latency involved in using cloud-based databases. But it will make a difference from the cost point of view as well. And the other related to that is use distributed caching service, cache across instances. So you're sharing that same database data across multiple servers without having to go back to the database for each server. Minimize number of queue reads. So you pay for the queuing services. You generally pay per queue check. That's regardless of whether you get anything out of the queue or whether the queue's empty. So think about when you're setting up a queuing service, do you need it to check every second or will every minute do? How frequently do we actually need to check the data? Is it better to check once an hour and process a load of queue entries there? And if possible, combine multiple requests into one queue entry. That may not be feasible because of the size limit to queue entries, but it's certainly something that's worth considering. And last one, or second to last one, sorry, is to think about licensing costs. So if you've got in-house licenses, then try and use those rather than the ones that pay the extra to get the EC2 licenses. So Oracle, Amazon RDS Oracle is a good example of this, that they give you the option of using your own Oracle licenses for a massively reduced fee. And that's anything else you've got licenses for in-house that Amazon or the other services charge for, then it's worth trying to use those, as it will minimise your costs. And then obviously open source options is always a good cost reducer. And the last one, and this is a key one, and this is probably the easiest one to fall into the trap of, is stop the servers when you're not using them, because you don't pay for them when you're not using them. So if you're using them for development, stop them before you go home at night and start them up again in the morning. That, you're saving 2/3 of the cost of those servers. I think anyone who's used particularly EC2 a lot will probably have fallen into that trap. It is easy to quickly run up a big bill by forgetting to stop servers. Okay, and I think just want to quickly talk about one of the main benefits of the cloud platforms is that they are built for scalability. And we've talked earlier on about making your app scalable, and the next sort of key thing to consider is making that happen automatically. So all of these services offer APIs into them, so you can programmatically control what's going on, and this could be done either manually or through some sort of automated process. So AWS offers a solution out of the box, auto scaling, which does something similar to this, but it's a matter of how you want to control it, whether you want more granularity on what it's doing or whether you're with another cloud provider who doesn't offer this. It's worth doing this so that your system can be scaled by non-sysadmin people. So if your e-commerce site is too busy, that whether or not to expand is a cost-benefit decision based on the amount of extra sales you'll be achieving rather against the cost of the scaling out the environment. And that shouldn't be a sysadmin or an IT decision. That should be a business decision that can be implemented quickly and easily by people within that area of the business. And the joy of the cloud system is that the APIs associated with them make that deliverable. Key consideration is auto expansion can become expensive, so you need to consider the billing implications, and it's particularly relevant if you get something that might be called the Kate Middleton effect, where Kate Middleton wears one of your dresses, which increases your traffic on your website by 20,000 times, but you've got a fixed stock, so you're not actually going to sell anymore. But if you're scaling out to some auto scaling system, that actually scales it out to 200 servers, so you can easily handle all that traffic, runs up a big bill, and you don't make any more money. So you need to, as with anything else, cost-benefit decision. Okay, that's all that I was going to go through today. So if anyone's got any questions at this point, or Alex, if any questions come through, then we can do those at this point.
Yeah, general sort of security-based questions, I think, which is always quite a hot topic when it comes to clouds, sort of in terms of using open source applications and services and cloud in general. What do you say to someone considered concerned about security?
Security is something obviously that people ask about a lot, and I think one of the key concerns is, that with the cloud offering, things are going out of your hands directly. So you don't have the direct input that you do in certain other areas. And my answer to this, and I'm not a security expert, but my thought has always been that you need to use the same level of common sense as you would with any other application. So you need to consider the security needs of your application. So, what sort of sensitivity do you have with your application? And rate, again, it's a risk-based approach that you have less control over the security on the web by the web providers, but depending on the level of security expertise you have in-house, the cloud providers possibly have a far greater level of security expertise, and security is obviously a major consideration to them, and they do everything within their power to maximise the security of their systems. Now, obviously, if you're working for a big company that has a security team in-house, you probably match or even exceed their levels of security. If you're working for a small company with no security levels in-house, managing your own servers, then their security expertise will far outweigh yours. To me, it comes down to a common sense approach: weigh up the risks, weigh up the benefits, and if you're concerned, consult a security expert and get some advice on it before you commit to it. Obviously, one of the advantages of the cloud as a platform is that you can try things out. You can roll out prototypes or proof of concepts, or even limited releases onto a cloud platform, see how it works, and then if it doesn't work, scrap it. And it's a throwaway solution, which you can try things out on it without any major investment, or traditionally, if you wanted to try something new and you went out and bought 5 servers for it, paid someone to install all the software, any licensing costs, then you were pretty much stuck with that. Whereas on the cloud service, you can obviously get that fired up in hours, get your stuff up on it, try it, see if it works, and if you don't like it, get rid of it.
Okay, great. What I'd add to that as well is that if you are looking to try something on EC2 especially, we do have CloudFlex as a product which simplifies that process, so you can look on the website for that. And I'd say if you want to talk to us about anything about development or performance or cloud services, then do get in touch. You can see the contact details there. But I think that does it for today, Andy.
Yeah, that's fine. Just to echo what Alex was saying, if anyone wants to follow up with me on anything I've said in that presentation, either to agree or disagree, drop me an email. You can go via the more intechnica.co.uk, or I'm at Andy_still on Twitter. So yeah, get in touch or get in touch with Alex, who'll forward it on to us.
Yeah, great. So thanks everyone for joining us. I will send out a recording to everybody during the week. And thanks very much.
Thank you.